Welcome, everyone. Congratulations, all. Congratulations. You made it to the very last algebra lesson of the year. Do you guys like what I've done with the place? I put up some streamers. I've got my good girl Becky in the corner. She's setting up the pin to tail on the donkey. And as a little treat for later, I even got DaBaby to perform for us over in the corner. Since some of you mentioned a couple months ago that him and I look exactly alike, I figured why not bring him in to bring the whole bit full circle. So it's going to be a great time. Actually, as a comparison, should I are we the same? Do we look the same? That's what I thought. Cool. Okay. Yeah. So I want you all to enjoy the festivities that I set up. But before we get into that, I do want to get into our last lesson for the year because, let's just get it out of the way and then we can enjoy ourselves a little bit and celebrate. So, this last section of chapter 8 is going to be multiplying special cases. So, we're going to be doing more multiplying of binomials like we did last week. But today, we're going to be focusing on some situations that are just a little different on ones that we haven't talked about before. So let's get right into it. So some binomials can be multiplied with special rules depending on what they are. So like last week, I gave you lots of tools and tricks to multiply binomials. This week, I'm going to give you two more that we're going to talk about today. And unlike last week, these will be ones that I highly recommend you use rather than an optional thing. So the first one I want to get into is a square of a binomial. Now we all know, or we all should know at least, what squaring is. But just as a reminder, if some term is squared, so if it's a number or a variable or whatever, we're multiplying that term by itself. So let's just do some examples to start us off. So if I've got 3 squared, or 3 to the second power, that just means I'm multiplying 3 by itself. So I'm doing 3 times 3, which should be 9. We all should know this at this point. If I've got a variable like x squared, I'm just doing x times x. And I didn't have another equal sign there because it's just x squared, but nothing else fancy comes from it. Or you could go crazy, go stupid, and you could have something like 6x, that whole thing squared. So I'm squaring not only a number, but a variable at the same time. So I'm doing 6x times 6x. So in a situation like this, we would just want to multiply our numbers separately and our variables separately. So I know that if I do 6 times 6, I'm going to get 36. And if I do x times x, well, don't forget, there's no exponent there, so I got 1 exponents, right? And when we multiply variables, we add those exponents, right? So for this one, I do 6 times 6 is 36, and x1 times x1 gives me x to the second power. So the full product is going to be both of those answers put together. So the number answer and the variable answer just slap together. But same thing, you just squared them individually and put those together. So just as a reminder of what squaring is, just wanted to make sure we got that down. So the main rule, oh, I gotta erase this. Cool. So if I want to do a square of a binomial, let's kind of break it down. So if I ask you to square, or no, simplify the binomial product right here, that is what it's gonna look like. So I'm going to make it general to start things off. So it's going to be kind of weird at first. There's going to be letters floating around, but I promise when it all comes full circle, it'll all make sense. So let's just use a very vague example to start stuff off with. So I've got one term, A. It could be anything. It could be a variable, a number, whatever. And I got another term, B. Again, it could be a variable or a number. We're just making it kind of general right now. It's just going to be A and B. And I'm squaring that whole thing. It's a whole binomial in this case. So if I want to solve this or simplify this, here's how we're going to break it down. Obviously, rewriting the square is going to help us out a lot. Having an exponent could make things kind of confusing, so let's kind of stretch that out a little bit. I know if I'm doing a plus b, that whole thing squared, I'm just taking a plus b times a plus b. I'm multiplying that whole thing by itself. So now that we've gotten written like this, it's kind of a little bit more in our wheelhouse. Now it's kind of like what we did last week. So my next step is that I would want to distribute those terms, or you could FOIL or do whatever method worked best for you. I'm going to go with FOIL method just because that's what I'm comfortable with, and it's what's going to get us to the answer the quickest, in my opinion. So I'd want to do my first term times the first term in the other binomial, so A times A, which same variable and no exponents, right? So they've got a 1 exponent. So a to the 1 power times a to the 1 power, well, that's just going to give me a to the second power, or a squared in this case. So that one's cool. Next, I'd want to do a times the other term, b. Now, I've got two different variables, and it kind of goes the same way when I talk about a variable and a number. Can't go together at all. This is the same thing if I've got two different variables. So a is one variable, b is another variable. Can't do anything with those, so we slap them together. So I'm just going to have a plus ab, and it's a plus because they're both positive. Now let's do the other set. So I'd want to do b times a, which I know reading it left to right, you'd want to expect it to be ba, which is technically correct, but I'm going to leave them in the same order as before, just so everything kind of makes sense and is a little more concise. So b times a, again, I just want to slap those together. So it's going to be ba, or we could flip it and make it another ab. I'm going to keep it that way, and you'll see why in a sec. And then my last set, I got to do b times b. And since those are the same variables, little different rules apply, right? Again, I don't have an exponent, so that's got a 1, that's got a 1. Ugh, that was a bad one. It's going to be the same situation with the a, right? B to the 1 times b to the 1 power is going to give me b to the second power. And it's a plus because they're both positive. So I've got this ugly, disgusting mess. What do I do now? Well, obviously, last week we knew that our last step should be to combine the like terms. And I know it looks a bit like a mess, but I do have a pair in the middle as usual. I've got one set of variables that's AB and another one that's AB. They both have the same variables, so they are like terms. Now, if I'm trying to combine those, I know that for this whole AB and this whole AB, there's no number in front of it, right? So if I don't have a number in front of variables, we know it's what? Boy, this is really not working. Oh, what? Oh, it's a 1, right? That's right. Yeah. So I know I've got a 1 in front of this AB and a 1 in front of this AB. So if I want to combine those like terms, I just have to add the numbers in front. So 1 plus 1, I'm just going to get 2. So my whole answer, I'm going to bring down my a to the second power because nothing happened at all. There was nothing I could combine it with. But then in the middle, I'm going to have 2ab because I added a 1 and a 1. And then to top it off, I bring down my plus b squared because there was nothing I could combine that with. So we've got another weird, disgusting mess, but this is where the important part comes from. So this form is what we're going to use to multiply binomial squares. This is like the blueprint right here. And once we use it in some examples, I think it'll make a little bit more sense. I'm not asking you to do any weird stuff with variables at all. I'm just showing you where the rule comes from. So let's actually put it into practice. Let's do what I'm actually going to expect you to do. So I got 3 examples. Oh, it's a mess. Okay. Okay. So I kept our rule at the side so we can reference it. I know that whenever I square some binomials, my answer is always going to look like this, no matter what. So let's try it out. So my first one is I've got x plus 4, that whole thing, squared. So let's kind of label things to start off with. My first term, I'm always going to assume that's a. So in this case, let's assume x is in that a position, that first position as before. And let's assume that the 4 is in that b position or that second position, just so we have kind of a frame of reference. I know that since it's going to come out to be a form like this, you don't even have to do distributing. You can just toss that out the window. So I just want to make these terms look like this answer right here. So I know my first term in this answer should be whatever the first term is, the a term, squared. Well, let's look over here. X is my first term, and I got to square it. So the first term is going to be x squared because it's my a term, it's my first term. The middle one is the weirdest one. I have to take 2 times my a term times my b term. So in the middle, I have to take 2 times x, my a term, and 2 times 4, my b term. And we'll kind of make that look a little prettier later. And then at the very end, I have to square my b term as well. So since 4 is the b term on the end, I'm going to have plus 4 squared. Now this is a mess. I would not take an answer like this. The second step would be to actually simplify it a little bit. So can I simplify x squared? No, that's about as simple as it gets. There's nothing you have to do with this. But over here with all this multiplication, I would expect you to simplify that. Now I've got 2 times x times 4. I always take care of the numbers first. So not even thinking about this x, if I'm doing 2 times 4, we know that gives me 8. And then 8 times x, a variable, well, we know we just slap those together, right? A number and a variable. So in the middle, you should have 8x. And then at the very end, you have to do this squaring. I would not take an answer like this. I would want you to actually rewrite it and simplify it. So I know 4 squared is just 4 times 4, so it should be plus 16 on the end. And that would be your final answer for this one. So we didn't have to do any distributing. We just set it up the way this form is because it's always going to turn out that way if we're squaring a binomial. Let's try another one. Let's do x minus 3, that whole thing squared. So again, my first term, let's say x is our a term, and let's say this minus 3 or negative 3 is our b term. So first term in our rule says we got to square the a term. Cool. So I'm going to have x squared because that's our a term. Then in the middle, I got to take 2 times my a term times my b term. So in the middle, I have to do 2 times x, my a term, and times negative 3. If you see a minus there, that is a negative. Do not get that twisted. So, and then at the very end, I've got to do plus my b term squared. So we want to have plus negative 3 squared. So this is a whole mess right here. So I would want you to simplify that. Again, can't do anything with x squared. It's about as simple as it's going to get. But then in the middle, let's multiply our numbers first and slap the x on at the very end. So 2 times negative 3, it's going to give me negative 6. And then negative 6 times that x, we're just going to put those together, right? So in the middle, you should have plus negative 6, or in this case, I put minus 6x because that number is going to be negative. And then on the very end, don't let the negative like trip you up at all. If I'm doing negative 3 squared, I'm doing negative 3 times negative 3, right? So negative times negative should be a positive. So you should have plus 9 on the end of this answer. So I will throw in some minuses and negatives, so watch out for those. But that's just how that one turns out. Then you're all done. And then my last one, I decided to be a bit of a jerk and just go crazy. So let's do 3x plus 5, that whole thing squared. Even though there's a lot more going on, same rules still apply right in the corner over here. So let's say you can't really see it because my toolbar is in the way, but the 3x will be our a term and the 5 will be our b term, right? So on the corner, I've got to have my a term squared. So we're just going to start off with 3x, that whole thing squared. In the middle, I got to have 2 times my a term times my b term. So in the middle, I've got 2 times 3x times 5. Cool, all set up. And then on the end, I have to square my b term, which in this case is 5. So we have plus 5 squared. That's an extreme mess. So I'd want you to fix that up real quick. You actually have to simplify all of them. So down here, this is going to be my worst nightmare right here. So I've got 3x, that whole thing squared. I'm doing 3x times 3x. So you'd want to square the numbers and the x's. So 3 squared gives me 9, x squared gives me x squared, right? So down here, I should have 9x squared. Down in the middle, again, don't let all these numbers trip you up. Just multiply the numbers and slap the x on at the end because there's only one x here. So I'd want to do 2 times 3 gives me 6, and then 6 times 5, which gives me 30, and then there's an x thrown in there, so we just slap that on. So in the middle of this answer, if that bar ever disappears, it's going to be plus 30x in the middle. And lastly, you should have 5 squared on the end, so it should be plus 25. 5 times 5. That is how these problems go down. So I'm never going to expect you to distribute with these. You can if you want to, but you have a really nice rule that's going to help you out way faster and just be a nice shortcut in general. And I know distributing can be kind of tricky for some people, so I really love this rule a lot. So that is our first one. Let's get into our second one. I just realized I never changed that. That should say rule 2 right there. I mean, is it really a Mr. Cecil lesson if I don't screw up like some of the answers? You know, that's just kind of how it goes. So, anyways, blanking. I'm blanking. Oh, yeah, okay. So, this one is the product of a sum and a difference. So, that's a whole mouthful of words, but we're going to get into it and just explain that a little bit. So, if I want to multiply the sum and difference of two terms, that's also going to produce some kind of rule. So let's kind of break it down a little bit. So a problem is like that is going to look like this. So I'm going to start off in a general form just so we can see where our rule comes from. So I'm still going to have two terms, A and B. They could be numbers, they could be variables, they could be whatever. Only this time in one binomial, they're being added, and in the other binomial, they're being subtracted. So it's different from before because in both of them, they're either being added or subtracted. In this one, it's got to be one and the other. And it's going to produce a slightly different rule. We'll see how that turns out. But again, same rules still apply. I want to distribute my terms to start off with. So I want to do A times A. So again, it's going to give me A squared. We already reviewed this. I got to do A times the other term, which is a negative B. So I'm doing A times negative B, two different variables. We want to slap those together too. But in your answer, you'll have to have negative AB or minus AB because this one was negative, this one was positive. Second set, I got to do B times A. They're both positive. So for this one, we'd have to have plus AB. And at the end, I got to do B times negative B. So I'm going to have B squared, but this one's going to be negative because we got a positive times a negative. So I'll have minus B squared. Again, I am never going to expect you to actually distribute this and do this. I'm just showing you where the rule comes from. So don't get scared right yet. This is actually the much easier rule to get down. So, and of course, I got to combine my like terms in the middle. So again, I don't have numbers in front of these variables, right? So I know there's a 1 here, and I know there's a 1 here. Now, if I'm trying to combine those, though, I've got a negative 1 plus a positive 1, which is 0. So in this case, these guys just cancel out completely, and I am just left with the stuff on the sides. So I'm going to bring down my positive a to the second power, and I'm going to bring down my negative b to the second power. So if you've got a product of a sum and a difference, your answer is always going to look like this. That is the blueprint or the rule for problems like this, which this one is way easier because you don't have that middle term with the 2ab in it, which is super nice. You only have to worry about two things. So these problems are actually a lot nicer and there's a little less to work with. So let's get into some of them to try them out. So if I've got products of sums and differences, here's what rule you want to follow by. A to the second power minus b to the second power. That's what your answer is always going to look like. So let's try this one. So I've got x plus 2 times x minus 2. Again, one of them has to be addition, the other one has to be subtraction in order for this rule to apply. And we got the same terms in each one as well. So again, let's point out what our terms are. So I'm going to make my x's my a term. It's always the first term, in my opinion. And my 2's are going to be my b term. So first term of this rule, I have to take my a term, my first one, and square it. Well, that's cool. It's just x, so first answer is going to be x squared. And then I have to have minus b squared, my second term. So in this case, I'm going to have minus 2 squared, because that's my b term. Now, I don't want you to stop here. There's one extra thing you can simplify. Obviously, we know x squared. I can't take that anywhere else, but you can simplify 2 squared a little bit. You can do it. So it should be minus 4, 2 times 2 up here. And that's it. So I like these problems because there's one less step and they took out the most confusing one from before. I think that 2AB can really mess people up sometimes. So having problems like this where they just take it out, I'm like, great, cool, fine by me. So let's try two more. I've got x plus 7 times x minus 7. Again, same two terms, but one's addition, one's negative. So let's make our x our a term and let's make the 7 our b term. So again, a term is just going to be a squared, so we'll have x squared. But then on the side, I'm going to have minus b squared. In this case, 7 is my b term, so I'm going to have minus 7 squared. And again, can't do anything with that x squared, but you can simplify that 7 squared a little bit. 7 times 7 is just going to give me 49, so we'll have minus 49 at the end right here. And my last one, obviously I got to go a little crazy, go stupid. Also, am I overdoing the go crazy, go stupid joke? Because I just always remember how adults and boomers would kind of just ruin jokes a little bit when it kind of finally got to them, after how long? And I just feel like I'm doing that a little bit, but I just genuinely think it's a hilarious thing to say. But if I'm overdoing it and I'm ruining the joke for you, please let me know and I will stop because I'm not trying to be a boomer at all, which I'm not. I'm 23, okay? I'm full of youth and I didn't kill the economy and the environment. Anyways, okay. So I got my two terms, 2x and 3. One of them is being added, one of them is being subtracted. So again, if that ever goes away, my 2x is going to be my a term, and my 3 is going to be my b term, but the same rules still apply. So first off, I got to square my a term, so we're going to square all of 2x. And then on the other side, we're going to have minus 3 squared. So if I'm trying to square 2x, I have to square both things. So I have to square the 2 and the x. So 2 squared is 4, x squared is just x squared. So our first term is going to be 4x squared. And then right next to it, 3 squared, we know this at this point, it's just 9. So I'm going to have minus 9. And then you'd be all done. So these problems are sick because there's just less work to do and it's an easier rule to follow and you just have to square stuff. So if you've got that down, you're going to be totally fine with this one. So that's the two rules for this one. That's all the new stuff for right now. So let's put it all together. So I've got a nice handy table with each type of special case and the rule that goes with it. So don't forget, if your problem looks like this, if I've got a plus b, that whole thing squared, I know the rule has got to be that weird a squared plus 2ab plus b squared. So I know it's got to look something like this. And the one extra thing I didn't talk about was that if I have a minus b squared, it's going to be slightly different. We did one example before, we'll do another one in a sec. But the answer will be the same. The only difference is that I'll have a squared minus 2ab plus b squared. So if you've got a minus b, that whole thing squared, this will be the only difference, but the same rule still applies. And the last step, the one we just talked about, the product of the sum and difference, if I have a plus b times a minus b, it's just going to be the super simple, super beautiful a squared minus b squared. So these are the rules we want to know. And honestly, it's not even 3 rules, it's like 2.5. So less work on your part. So if you've got these down, this section is going to be a breeze. You are about to end algebra on a high note for sure. So let's try a couple together to wrap it all up. I need to take a drink first before my vocal cords die. I tested my mic before this to make sure everything was working because, again, last week filming a lesson only to find out that the audio magically turned itself off made me just have a total breakdown. And I'm not trying to do that again. So we'll see how it goes. Anyways, so let's try some simplifying. So my first one is I've got x plus 5, that whole thing squared. So looking at this, first we need to identify what rule we should work with. Since I've got a whole thing squared and it's not separated into 2 parts, I know it's going to be a square of a binomial, right? If you see that 2 up there, you should automatically know it's the square of binomial rule. So I know it's got to be this bad boy right here. And since it's a plus 5, we should have plus 2ab on the corner. So I'm going to make my x my a term and my 5 my b term. We should know this by now. First one's a, second one's b. So I got to square my a term, which is just x squared, which, pretty overdone at this point, but that's just how it goes. So in the middle, I've got 2 times my a term times my b term. So I've got 2 times x times 5. And on the end, I want to have plus b squared. 5 is my b term, so I've got plus 5 squared. And obviously, I want you to simplify it down a little bit. So again, nothing going on with x squared. Nothing happens with that. But in the middle, I want to multiply my numbers. So 2 times 5 gives me 10. Times this x, we just slap that on. So I've got plus 10x. These are all positives here. And on the end, plus 5 times 5, or 5 squared, gives me 25. You're all done. A breeze. You got it. Let's try another one. I went a little crazy with this one. So I've got 3x minus 1. Now there's a lot going on the inside, but all you really need to pay attention to is on the outside. I've got a square here, so I know it's got to be the square binomial rule. And in this case, I've got a minus, so it's got to be a squared minus 2ab plus b squared. That's pretty much it. So 3x is my a term, so we got to square that first off. So I've got 3x, that whole thing squared. In the middle, I've got 2 times 3x times 1, and it's going to be minus, so keep that minus in there. So I've got minus 2 times 3x times 1. And at the end, I want to square my b, which will be, well, this should have been a -1, which is my bad, but it'll end up being positive anyway. So that was my bad. That should be a negative right there. Look at that. I caught one of my mistakes before any of you guys could. That is growth on my part. That is growth right there. Okay. So first off, I got to square my 3x. So 3 times 3 gives me 9. X times x gives me x squared. So I'm going to have 9x squared in that first one. Second one, I want to multiply my numbers. So 2 times 3 gives me 6. Times 1, still 6. And we have an x thrown in there as well. So I'm going to have minus 6x. And at the end, -1 times -1 is just going to give me +1. So plus 1 on the end. So I will throw in some minuses, so watch out for that. And as my last two, I got 2 more. We'll do some differences and sums. So I've got x plus 11, x minus 11. Since it's already separated into 2 parts, we should know what problem this is. This is a plus, this is a minus, so I've got to do that product of the sum and difference. The super easy one where it's just a squared minus b squared. Obviously, x is my a term, so I've just got x squared to start stuff out with. And then I have minus b squared, which is 11 in this case. 11 is my b term, so I've got minus 11 squared. Again, can't do anything with x squared. We know it. We've been through it. 11 squared, just 11 times 11. Calculators are our best friends, so I should have minus 121. That's it. That's all I got to do. My last one, I wanted to go a little crazy. So I've got 4x plus 9, 4x minus 9. I got 2 binomials. One is adding, one is subtracting. So you got to use that sum and difference product rule. So again, that a squared minus b squared. First term is 4x. We'll say that's our a. So I got to square that whole thing. And then my second term is 9. So I have to have minus 9 squared. So I'd want to simplify both of these. I would not take this as a final answer. You got to put in a little extra work. So if I do 4x times 4x, 4 times 4 is 16. X times x is x squared. Put those two together. So I've got 16x squared as an answer. And the last bit, minus 9 squared. 9 times 9 gives me 81. So I should have minus 81. That's it. You are all done. Literally with the problem and with this lesson, because that's all I got. We're ending on a simple note today. I feel like the progression of chapter 8 was like, oh, we're talking about polynomials, and oh, let's do some factoring, and oh, now we're multiplying, and oh, it's just more multiplying. So kind of ending on kind of a low note, but it's not a super challenging one, at least, from my perspective, but I'm a little biased. I Hope you all are making it through okay. It's weird that this is like my last lesson, but I'm done like a whole week before school would have ended anyway. It's weird. This is a weird situation, but um, please let me know if you have any questions at all. I miss you all. And again, I'm going to be teaching Algebra 2 next year. So maybe I'll have some of you again. And maybe that's a bad for you. I don't know, but it'll be make me happy to see your faces again in class. And yeah, so enjoy the party that I threw. Give Pin the Tail on the Donkey a try. Say hi to DeBaby for me. He was not cheap to book, so make sure you really enjoy that. And I hope you all make it through this last week okay. So let me know if you got questions. So long, everyone.